and welcome to Shakina's Math Center. In this video, we will be converting improper fractions into mixed numbers. The only materials needed for this lesson are paper and pencil. Take a moment, grab what you need, and let's get started. Here we have 16/3. Our first step is to look at the denominator. This will tell you how many parts it takes to make one whole. For this problem, it takes 3 parts to make one whole. Let's draw one whole using a rectangle. We want to section this off into 3 equal parts. Here we have 1/3. Here's another 1/3. Here's another 1/3. And the whole entire rectangle is worth one whole. We need 16 of the 1/3. So far, we only have 3. So essentially, you want to skip count by your denominator. In this case, it's 3, without going over 16. Let's draw more 1/3. This is 1/3. This is 1/3. This is also 1/3. And this is a 4th, 5th, and 6th. So far, we have 2 wholes. We have 6 1/3. We need 16. So we have to keep going, getting as close to 16 without going over. So this is a 7th, 8th, 9th. This is a 10th, 11th, 12th. This is a 13th, 14th, 15th. We will draw one more whole. However, we will only use one of the thirds. We're not going to use this one or this one. Here is 1/3, and this is a 16th. Here we have 1, 2, 3, 4, 5 wholes. This is why we skip count by 3, but don't go over 16, because here we have 3, 6, 9, 12, 15. So we skip counted 5 times, and we have 1/3 left over. 16/3 is equal to 5 1/3. Here we have 9 halves. Our first step is to look at our denominator. Our denominator is 2. This means that our wholes are broken up into 2 equal parts. Let's draw our one whole. And we are going to divide it into 2 equal parts. This is 1/2, and this is 1/2. We need 9 of these. So far, we only have 2. So let's keep going. We need to get close to 9 without going over 9. This is a 3rd. This is a 4th. This is the 5th. This is a 6th. This is the 7th. This is the 8th. We are going to draw one more, but we will not use the whole thing. We're only going to use this one. So we're going to X this one out. So remember, you skip count by your denominator. 2, 4, 6, 8. That gives us 4 wholes. And we have 1/2 left over. So 9 halves is equal to 4 1/2. For this problem, we have 7/5. We are to look at the denominator, which is 5. That tells us how many equal parts our whole is broken up into. Let's draw our whole and section it off into 5 equal parts. Each part is worth 1/5. And so far we have 5 of them. 5 of them make up one whole. We need 7 of the 1/5. So we're going to draw one more group. But we won't use the entire thing. We need 7. So this is the 6th, and this is the 7th. We are not going to use this one, or this one. So remember, the rule is to skip count by 5, but do not go over 7. So we do that. This is 5, and that's it. We only skip counted one time. We have 2 left over, 2 of the fifths. So 7/5 is equal to 1 2/5. In this problem, we have 14/4. We need to look at our denominator. It is 4, meaning our whole is broken up into 4 equal parts. Let's draw our one whole. And we are going to divide it into 4 equal parts. This is a first, second, third, and fourth. We need 14 of these. So let's keep going, but do not go over 14. This is a fifth, sixth, seventh, and eighth. Let's keep going. This is the 9th, 10th, 11th, 12th. We are going to draw one more hole. We're not going to use all of these pieces because if we do, we'll go over 14. Okay, so this is the 13th, 14th. We're not using this one or this one. Remember, skip count by 4, but do not go over 14. So 4, 8, 12. That gives us 3 holes with 2 left over out of the 4. Here we can simplify this and make this 3 1/2. Here we have 7 halves. So remember, skip count by 2, but do not go over 7. So let's draw this out. Draw your one whole. Separate it into 1/2. This is 1, 2. Keep going, but do not go over 7. This is a third, fourth, fifth, sixth. We can only draw one more and we won't use the whole thing. This is the 7th. Cross this one out. Here we have 2, 4, 6. That is why you're skip counting by 2. So that gives us 3 wholes with 1 left over out of the 2. So 7 halves is equal to 3.5. Now let's practice a few problems without drawing the model. Remember to skip count by your denominator without going over your numerator. For this problem, our denominator is 4. So we are going to skip count by 4, but do not go over 11. So 4, 8, 12. We have to stop at 8. We cannot skip count up to 12 because that will put us over 11. So we've skip counted 2 times. We stopped at 8 and we need to get to 11. So there are 3 of those fourths left over. So 11 fourths is equal to 2 wholes and 3 fourths. For this problem, we are going to skip count by 5 and not go over 29. So that would be 5, 10, 15, 20, 25, 30. Okay, so we cannot skip count up to 30 because that will put us over 29. We skip counted 5 times. We stopped at 25, but we have 29 parts. So there are 4 parts left over of those fifths. So 29 fifths is equal to 5 and 4 fifths. For this problem, we are going to skip count by 3, but do not go over 32. We know that 3 times 10 equals 30. And we also know that 3 times 11 equals 33. So we cannot skip count up to 33 because that will put us over 32. So that means for 32 thirds, we are skip counting 10 times. And there are 2 parts left over because 3 times 10 is 30. There are 2 parts left over out of the thirds. So 32 thirds is equal to 10 and 2 thirds. For this problem, we are going to skip count by 8, but do not go over 26. So 8, 16, 24. We're going to stop there. That is 3 times. If we skip count anymore, that'll put us well over 24. We stopped at 24 and there are 26 parts. So that means there are 2 left over out of 8. This problem can be simplified. So this is 3 and 1/4. Because here we would divide by 2, and that would get us 3 and 1/4. Now it is your turn. You got this.